Multiply polynomials, you're really just doing the distributive property. And sometimes you're doing the distributive property more than once. If I had just given you 5 distributed to x minus 7, this is something that we've done already this year. Remember, this is a 1x, so you would have taken 5 times the 1x and gotten 5x, and 5 times negative 7 and gotten negative 35, so you would have 5x minus 35. The difference here is this is 5x times a 1x minus 7, but the distributive property portion of it is the same. The 5 times the 1 is 5, and then the x times the x is x squared, because 5x times 1x is like 5 times x, which is what 5x means, times 1 times x. And there's a commutative property of multiplication that says I can rearrange these. So I can bring the 5 times 1 out to the front, and then put the x times x together. So that's really what I'm doing here. And then 5x times the negative 7 is negative 35x, so I'm going to write minus 35x. And that actually is the answer. It's written in standard form. The x squared's before the x. I can't combine those because they're not like terms. Now let's use this thinking over here. 3x cubed is like 3 times x cubed. And I'm going to multiply it by a 2x squared, so times a 2 times an x squared. The 3 times 2 can come out to the front, and that's 6. X cubed is like x times x times x. X squared is an x times x. And what I notice is when I'm done, I end up with 5 x's multiplied together, so this is x to the 5th. 3 times negative 10 is negative 30. I think about it, I had 3 x's and I multiplied by another x, so I have 4 x's multiplied together. 3 times 7 is a positive 21, and then I had this x cubed and no more x's to multiply it by, so it stays an x cubed. That's written in standard form, x to the 5th before x to the 4th before x cubed, and I'm done. Now, this actually means to distribute each of these terms to each of these. So I'm going to take the x from the first one and multiply it, distribute it to the x plus 9 in the second set of parentheses. And then I'm going to take the negative 7 from the first one and also distribute it to the x plus 9. Now don't forget the negative, the minus, bring it down as a negative in front of the 7. X times x is x squared. X times a positive 9 makes this a plus 9x. Negative 7 times x is a minus 7x, and negative 7 times positive 9 is a negative 63. Now, I have like terms here, because I have two different just x terms. So notice I lined those up vertically. So I get x squared. When I'm gaining or losing terms, when I'm combining like terms, this is like I had a positive 9x. I had 9 x's, and then I lost, think of subtraction as losing, 7 x's. So I only have 2 x's left. And then I bring down my minus 63, and I'm done. Now that's one way to show the work on these that is acceptable. There's another way that I'm going to use that does the same thing. It's still distributing, but it doesn't make me copy quite so much. I don't have to copy this x plus 9 down twice this way. So I'm going to use, if I'm taking 2x minus 11, 2x minus 11 times 3x plus 5. Because really, each of these terms just has to be multiplied by each of these terms. This will do that. The 3 times 2 is 6. X times x is x squared. This one would be multiplying negative 11 times 3x, so that's a negative 33x. This would be multiplying positive 5 times 2x, so that's a positive 10x. And this last one is multiplying this negative 11 times the positive 5 for negative 55. Now I like this method because I don't have to write the second polynomial twice, and my like terms are still lined up, they're just lined up on a diagonal. So I have a 6x squared term. My x terms, I had 10 x's, but I lost, because subtraction's like losing, 33 x's. So now I'm 23 x's in the whole, and then I've got my constant, my minus 55. Either one of these two methods is perfectly acceptable to show your work. Choose which of these two methods you prefer, and use it. I'm going to continue to use the lattice. Now to square something means to multiply it by itself. And you have to think about that. So this is really a 4x minus 9 times another 4x minus 9. Squared means multiplied by itself. So I'm going to go back and use my lattice. I've got a 4x minus 9, and I'm going to multiply it by another 4x minus 9. So I have 4x times 4x. 4 times 4 is 16. X times x is x squared. Negative 9 times 4x is a negative 36x. Negative 9 here times this 4x is another negative 36x. And then down in this box, negative 9 times negative 9 is a positive 81. Now I'm going to combine my like terms, so I have a 16x squared. I was 36 x's in the negative, and then I lost 36 more x's, so I'm 72 x's in the hole by the time I'm done, and then I've got my constant, my plus 81, out at the end. Now in this case, there is a missing x squared term. I like to keep my like terms lined up on a diagonal here in my box to make it easier to find. So I'm actually going to leave a row for the x squared term just to leave that space. So I'm going to need 3 columns because I'm going to need a 5x squared, and I'm going to need, a minus 4x and a plus 9. Over here I've got a 6x cubed, which is 6x to the third power. I have 0x squared, but I'm going to leave a row for it. And I have a positive 3x and a minus 4. So 6 times 5 is 30. Think about your x's. You had 3 x's multiplied together, then you're multiplying by another 2 x's. That's 5 x's total multiplied together. 6 times negative 4 is negative 24. Add 3 x's multiplied by another x is 4 x's multiplied together. 6 times 9 is a positive 54. And then I have this x cubed with nothing else to multiply it by. I'm just going to leave this blank. 3 times 5 is 15. And then x times x squared is x to the third power. I had 1x multiplied by 2 more x's. That's 3 x's multiplied together. 3 times negative 4 is negative 12. X times another x is an x squared. 3 times 9 is 27. And then I have this x and no other x to multiply it by. Negative 4 times 5 is negative 20. And then I have an x squared. I'm kind of running out of room here. Negative 4 times negative 4 is a positive 16. And then I have that x and no other x to multiply it by. And negative 4 times 9 is a negative 36. Now the reason I did that is that my x to the 5th, here are my x cubes, there's my x to the 4th, here are my x squareds, these are my x's. So each diagonal has my like terms on it that I can combine. So I have a 30x to the 5th, a negative 24x to the 4th, so minus 24x to the 4th. I had 15x cubes, and then I got, speaking of addition is getting, 54 more x cubes. So that's 69x cubes. I was 20x squared in the whole, then I lost 12 more of them, so I'm 32x squareds in the whole. I had 16 x's and I got 27 more x's, so that's 42 x's. And then I've got this minus 36 constant at the end. That is standard form, x to the 5th before x to the 4th, etc., 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 with the constant at the end. Again, if you prefer not to use the lattice, you may show this method. Do not think that this is sufficient work. It is not. One of the 2 methods that I wrote out in the notes is what you need to show.